Hello children, nice meeting you all. Today we are beginning a fresh chapter, that is work, power and energy. In today's class, we shall understand the proper meaning of work done in physics with some examples. So let us begin our class. Work, power and energy. Children, in daily life, we observe people doing different types of work. For example, studying, reading, thinking, sleeping, and many more. And these categories of work done generally come under mental work. What are they? Mental work. Apart from that, there are some work done like lifting a heavy load, or carrying a bucket of water from downstairs to upstairs, drawing water from the well. These all include some physical or mechanical work. So only these work done, that is physical and mechanical work done, are only considered as your work done in physics, but never the mental work. I hope you got the clarity, children. To get you more clarity regarding this work done, I'll be giving you a few more examples. Consider an engine pulling the train on the rails. In this case, the engine performs work done. So, some movement is being observed. So, some motion is caused and some force is acting on the train. So, this is again a mechanical work done. Not only this, children, observe a horse cart. The force exerted by the horse in pulling the cart in forward direction, also considered as work done. Similarly, a person climbing the stairs upstairs. Climbing the steps upstairs is also considered as work done. So, in order to understand deeply regarding the work done, let us try to define the same. So, what exactly is the work done, children? Work is said to be done when a force produces motion in the body. What is that, children? The force must produce motion in the body, and but where? In the direction of the force applied. In the direction of the force applied. So, definition of work done. Work is said to be done when a force produces motion in the body in the direction of force applied. In the direction of force simply. So, what is work done, children? Work is said to be done when a force produces motion in the body in the direction of applied force. The same work done can be defined mathematically as the mathematical definition of work done. So, this is one definition and here is mathematical definition. So, mathematical definition includes the product of force exerted on the body. So, what is the definition, children? Definition for work done is defined as the product of force exerted on the body and the distance moved by the body in the direction of force. So, what is the definition of work done, children? The product of force exerted on the body and the distance moved by the body in the direction of applied force. So, this is the mathematical definition, whereas the latter is the general definition. To understand clearly regarding the mathematical definition, so let me also write it in the latter way. Product of force. Force, let me represent with letter F. Product of force exerted on the body. Product, it should be multiplied. And the distance moved by the body. And the distance moved by the body in the direction of applied force. So this is the definition of work done. So what is work done? Work done is defined as the force exerted on the body and the distance moved by the body in the direction of applied force. So this can also be written in simple format as W equals to F into S. But here S indicates the distance moved by the body in the direction of applied force. So work done is a scalar quantity. What type of quantity, children? Work done is always a scalar quantity. Even though it has a magnitude, it also having certain direction, but still work done is always considered as a scalar quantity. Let us discuss in detail regarding the units of this work done. So one point you need to remember, children, work done is a scalar quantity. Even though force is a vector quantity, displacement is also a vector quantity. Displacement in the sense distance moved by the body in the direction. So which is having both distance, length covered as well as the direction. So it is a vector quantity. Force obviously is a vector quantity, but still the product of the two vectors, here you are giving a scalar quantity. Okay. So regarding this in detail, why it is a scalar and all, you will be learning it in the vectors topic, children. So for the time being, let us consider the units of this work done. So two types of units. Work done as mathematical expression, as we know that work done is equals to force into displacement. Displacement is nothing but distance moved by the body in the direction of force applied. Displacement is a vector quantity which includes magnitude as well as direction. Magnitudes means how much distance the body covers. Direction means in which direction the body is moving. Okay. So work done is equals to force into displacement. Coming to the SI units. Work done in SI units is measured in joules. Work done in SI units is measured in joules. So, indicated with the letter J, which is equals to force, is generally measured in newtons and displacement in meter. So, 1 joule is equals to 1 Newton meter. So, what are the two different units of work done, children? In SI units, one is joules and the other is Newton meter. Not only this, children, as W equals to F into S, F is measured in Newton and displacement is measured in meter. But we know the formula for force as mass into acceleration. Formula for force is mass into acceleration. So, mass is measured in kg and acceleration is measured in meter per second square. So, the value of 1 Newton can be written as 1 kg meter per second square. So, instead of Newton, I can also replace the Newton with the kg meter per second square. So, Newton is written as kg meter per second square, and not only this, children, multiplied by Newton, I wrote it as kg meter per second square into meter. So now meter into meter will give you meter square. Hence, the units for work done is kg meter square per second square. So what is that? Kg meter square per second square. So these are the different units of work done in SI system. One is joules, the other is Newton meter, and also kg meter square per second square. Similarly, if we dive into the CGS units of work done, in CGS system, work done is measured in ergs. Measured in erg, or In CGS system, force is measured in dyne and displacement is measured in centimeter. So it might be erg or dyne centimeter. The same force in CGS system when measured in dyne, which is equals to mass is generally measured in gram and the acceleration in CGS system is measured in centimeter per second square. Hence, the CGS units of work done is gram centimeter per second square into the force I have written as, for force I wrote it as gram centimeter per second square multiplied by displacement. So again displacement is measured in centimeters. This centimeter into centimeter will give you centimeter square. Hence, these are the different units for work done. Joule, Newton meter and kg, meter square per second square in SI system, whereas erg, dyne centimeter and gram centimeter square per second square.